Good morning, students. So, I hope everyone safe in your home, and I hope everyone follow the chapter 7 thoroughly in all videos, in all previous classes. So already we discussed chapter 7, that is idea of algorithmic efficiency. Okay, in last 6 to 7 video classes. Okay, so in all these classes we discuss the basic concepts of idea of algorithmic efficiency, how to calculate complexity of algorithms. Okay, in this we define first what is meant by algorithm. Okay, so already we completed that concept, idea of algorithmic efficiency. Today we discuss the complete overview of that is recapitulation of the complete chapter 7 idea of algorithmic efficiency. Already we discussed in previous classes. First we define the algorithm, what is meant by algorithm, and how to write algorithms, what is meant by flowchart. Okay, what is meant by computational complexity. Okay, what factors that are affected by the computational complexity. So there are two types of computational complexity, that is time complexity, space complexity. Time complexity, space complexity. Space complexity. So these time complexities, space complexity means what is meant by time complexity and space complexity, and what are the factors affected by the internal factors and external factors affected by the algorithm performance or efficiency. So how to measure the complexity, how to measure the performance or efficiency of the algorithm basing on these two criteria, time complexity and space complexity. In this chapter we will only focus on the computational complexity of time complexity. Okay, then after that we define the concepts best case, worst, average case, okay, worst case time complexities. Okay, best case time complexity, average case and worst case time complexities. After that we completion of, after that worst case complexity, we move to examples. How to calculate through examples, calculate the computational time required. Okay, we assign constant time each and every statement of the program. We explained previous classes to when we are giving one prime number. Okay, when we are giving one number, so that we decide that number is the given number is prime or not, basing on two techniques. That is, one is factors definition through basic concept of prime number definition, that is linear approach, that is calling it as linear approach technique. So prime number, example, prime number, whether the given number is prime or not. So two approaches, one is linear approach, second one is root n approach. Okay, root n approach. So after that we calculate here linear approach, order of n is equal to n here order of n is equal to root n. So which one is the best one? Root n is best one. Among these two we decide in that concept. Okay, after that we check the searching of an algorithm, searching of a element, using linear search. Second one is binary search technique. So linear search and binary search technique. See, linear search, okay, in linear search, the time complexity, here it is n. Okay, in binary search, the time complexity is n power half. Then we compare their, okay, these two time complexities. Which one is the best one? Binary search complexity n by 2. N by 2. That's why. Why? Because here entire search process is going on. So when we increase the input size, okay, when we increase the input size, our problem can be decomposed into smallest number of sub problems, each and every time half the problem. So that's why here n by 2. Here n. Which one is the best one? So n by 2 is less than n. That's why we decide binary search technique is the best one among all these two techniques of searching of an element in a given array or list. So all these concepts we discussed, okay, in previous classes. So today we discuss all the concepts. So recapitulation or revision of this entire chapter in within 1 or 2 classes. So we discuss first what is meant by algorithm. What is meant by algorithm? So what is meant by algorithm is a step-by-step process. Step-by-step process to solve a particular problem. To solve a particular, an algorithm is a step-by-step process to solve a particular problem in a domain. So when we write any programming language, whether it is C, C++, Java or Python or .NET, okay, we first take one algorithm with general format. It is a general format. It is a general format. All the steps are, okay, placed here, okay, in a step-by-step process, all the generals. So then we apply this algorithm into any programming language. Any programming language. That is calling it as program. Any programming language, that is calling it as. So why we convert this algorithm into programming language? I am asking one question here. How we convert? Why we convert? Or how we convert this programming algorithm into the general format of this algorithm? Logical. It consists of logical steps. This algorithm consists of logical steps. So all these logical steps we convert into our, according to our C language, any programming language, that is calling it as program. So programming language, then we convert this algorithm into any programming language, that is calling it as program. So why here we are using program means C language, C++, Java, okay, Pascal, COBOL, .NET and Python. So we convert the same program, all the logical step-by-step process steps convert into either C, C++, Java, Pascal, COBOL, .NET and Python languages. So this is the concept. First we write algorithms in a step-by-step process to solve a particular problem in a particular domain, related to particular domain. So after that we convert this logical steps, general format, So which is a general format that can be converted to according to our C language syntax. We follow here different syntax, means rules. Syntax means we follow some structure. For C language, C++, Java, Pascal and COBOL, different structures. All these having different structures. Our Python language also having object-oriented structure programming language. Object-oriented programming language. So we convert this algorithm into object-oriented programming language. Okay. So next, coming to what is meant by flowchart. So flowchart is a pictorial representation of. It is a pictorial representation of a graphical or pictorial representation or graphical representation or pictorial representation of an algorithm. Of an algorithm is called a flowchart. So, what is meant by flowchart? A flowchart is a pictorial representation or a graphical representation of algorithm is called a flowchart. First, we define the algorithms in a English general format. After that, we convert that general format steps into different symbols in a graphical manner. So that is the concept of flowchart. We are using different symbols. This concept we already discussed in first year topic. So that's why we not depth. Okay. So in depth we not see that topic. Just we define the basic concept of flowchart. So after that, so what is the meant by how to measure the complexity and what is meant by complexity of algorithms. So complexity means measuring. Complexity means so computational complexity. Computational means calculation. Okay. So computational complexity means calculation of efficiency or performance of an algorithm. So we calculate here the time computational complexity of efficiency or performance of an algorithm. In this chapter we discuss fully 100% we focused on this concept. So computational complexity of efficiency or performance we measure here, we determine or measure. Okay, we measure or determine the performance or efficiency of an algorithm. How to measure and how to determine the performance or efficiency of an algorithm basing on different factors, internal and external factors. So here the computational complexity depends on two factors. They are, first one is internal factors. Second one is external factors. So we measure the computational complexity of an algorithm. That means we calculate the efficiency of an algorithm. When we are increasing the input size, how to behave that algorithm and what time it to run that program and how much of time it takes to run that, to complete that program and how much of space it occupies. All these are considered as different factors of this computational complexity. So the computational complexity depends on two factors. First one is internal factors, second one is external factors. So here the internal factors are, these two are internal factors. So temporal complexity complexity means this one is also called as time complexity. This temporal complexity means time complexity. The second one, internal factors that are decided. So this one is space complexity. Space complexity. So these two are internal factors. So first one is internal temporal complexity, second one is space complexity. These two are considered as internal factors that are decided. Okay, the computational complexity. Okay, so first we discuss what is meant by temporal complexity and space complexity. So temporal complexity means, so temporal or time complexity means, time complexity means, okay, the time taken to run the program. So how much of time it takes to complete to run the entire program, that is calling it as temporal complexity. We measure the time complexity, we assign constant time factors and we decide order of n, that is calling it as temporal or time complexity to complete the program, to run the program. Okay, so next, space complexity. Space complexity means how much space, okay, is required or occupied when you are executing this program. So these two are, so how much space when you are executing any program, it requires some amount of space to store that program statements and to store all the created variables data in memory. So it requires, suppose I am decide one integer variable, okay, in a program with the variable a, int a means here in a is integer value, that's why it takes 2 bytes of memory. So it occupies 2 bytes of memory. In this way, variables occupy some memory and the statements that are contained in the program are also placed in memory. So how much of space it takes, okay, to occupy, it occupies, that can be calculated here. So we completely focus on this chapter, time complexity or temporal complexity of an algorithm here. So this is the internal factors that are this, these two factors are called as internal factors. One more factor, that is external factors. So the external factors are, so up to now we discuss about the internal factors, then we decide the external factors. See, the external factors are, see here external factors, there are, second one, external factors. When you are calculating complexity or, so external factors means we are executing our programs, okay, in any system. The system consists of 16-bit computers, the processor, 16-bit computers or 32-bit computers or 64-bit computers. Okay, so 16-bit, 32-bit or 64-bit computers. So we execute. So here we are executing that program in which, okay, process we execute. That also one of the factor, okay, to decide the, that is internal external factor. Okay, so external factors means, so whether we are using processor speed Okay, that is 16-bit speed, processor speed. Okay, this one is one of the factor to decide how much time it requires. Okay, one program performance depends on this processor speed and length of the length of the 16-bit or 32-bit or 64-bit computers or system we are using. So these are external factors we are affecting the complexity of algorithms. So whether you are using 16-bit computers, less slower than 32-bit computers. So we are using 64-bit computers, 32 bits are, when it compares to 64-bit, 32-bit computers are slow. So these are depends on the factors. These are called as external factors. Then what compilers? Compiler, the type of compiler. So next we decide the type of compilers. So with this program, every program must and should translate into high level language program, must and should translate into machine level language. HLL can be converted into MLL. So the actual process is going on by using either compiler or interpreter. So we are using here either compiler or interpreter. In our Python programming language, we are using here interpreter. So here the type of compiler or interpreter is one of the factor. So the speed of this software, okay, the performance of this software is also one of the factor to decide the computational complexity. So all these, so speed, length of the system, so and also compiler type or interpreter type, these are the external factors that are decide the complexity of these are the factors considered in external factors. So in this way we discuss about the internal and external factors that are affected by the performance or efficiency of algorithms. Okay, then we decide, so here the length of the input also one of the factor. Length of the input size. Length of input size is also affects the complexity. When you are calculating complexity, so the length of the input size. So every time we are not giving same input. So we change the according to our requirement. We are giving different input sizes. So the input size is one of the factor to decide to calculate the complexity, that is time complexity. So whether we are increasing our input size, it takes execution is. So we calculate how much it increases or how much time it reduces. So the input, the length of the input size is also one of the factor we decide the performance or efficiency of algorithms when we calculate it. See here, so basing on this, the length of the input size, we finally conclude that three types, that is best case, best case complexity, average case complexity, next finally worst case complexity. So basing on that input size, we decide three types. So whether we increase the input size So depends on that input size, we decide these three factors. That is, so best case complexity, second one is average complexity, third one is worst case complexity. So best case complexity means when you are increasing. So for example, the best, already we discussed for this three categories explained through this one example, linear search technique. Already explained these three concepts. So whether we are searching one element in a list of elements, so our search element is first element. So when we key search element, okay, is compared with list of elements in the given list or array. So first element is matched with our key search element. Then we decide the first location our key search element is formed. This is the best case. This is the best case because here only one comparison. Here we only one comparison required for this output. So easily we get the answer. That's why that is calling it as best case. So best case means we are getting the output with low comparisons. Means our input size is very low here. That's why we are getting fastly our output. So average case means every program we estimate some amount of time. So it reaches that estimated time, that is calling it as average case complexity. So best case means it is less than the estimated time. Best case means best case is always less than our estimated time. Estimated time. This estimated time is average case complexity time. So best case complexity is always an estimated time. So if worst case is always greater than estimated time. So this one is optimal. Best case is also called as optimal case. Optimal solution. So it returns always optimal solution. Why? Because here always average, every program we require some estimated value. That estimated value, this value, best case complexity value is always less than average case complexity value. That's why this is optimal. It returns optimal solution. So this optimal solution. So it returns this best case complexity returns minimal comparisons of the input. Minimal comparisons of the input. So minimal time we get the answer in a minimal possible input. Okay, minimal possible input. When we consider the average case complexity, okay, we are giving, okay, average complexity here. See, this one takes some estimated amount of it reaches estimated time. First we calculate estimated time, it reaches estimated time. So here this one estimated of takes average comparisons. So average of inputs, the length of the input here is average case. So when we consider worst case, okay, when we consider worst case complexity, okay, here it maximum, okay, when we consider this worst case complexity, okay, it takes maximum possible solutions or inputs. It takes maximum possible input. Why? Because here, so in our searching of an element program, so last element, when we compare all the elements, our key search element is not found in that program. So we decide finally the key search element is not found in our linear search process. That is calling it as worst case. Or otherwise, we search the element in the last comparison. Last comparison. That is, we found the element in the last position. So we compare all the n comparisons. Then we decide the location of our key search element. So here our key search problem increases the size of the comparisons. That is calling it as worst case comparison, worst case complexity. Maximum possible comparisons here requires. So in this way we categorize best case complexity, average case complexity, worst case complexity. So these three decides the complexity of a algorithm and performance of the algorithm. This is the today's class. We discuss remaining concepts tomorrow. Okay, everyone follow this complete chapter of the previous videos. Thank you, students.